In a shocking turn of events, NASA has shut down the Voyager 1 probe after it captured something bone-chilling in deep space. The alarming event has left scientists baffled and raised questions about the existence of supernatural. In 1977, NASA launched the Voyager 1 spacecraft, embarking on a mission to explore the outer reaches of our solar system and beyond. For over 4 decades, Voyager 1 has been hurtling through the cosmos, collecting data and beaming it back to Earth. But according to a recent news, NASA will be shutting down Voyager 1. Is it true? Why would NASA shut down a spacecraft that transmits data to Earth, even after more than 44 years in space? Before we discuss that, it is empirical to mention some of the most groundbreaking findings of NASA's space toy. In 2012, Voyager made a discovery that would send shockwaves through the scientific community and leave us questioning our place in the universe. Voyager 1's major finding was the existence of a boundary known as the heliopause, where the influence of the sun's solar wind gives way to the interstellar medium of the galaxy. It had been theorized for decades, but it wasn't until Voyager 1 crossed this threshold that scientists were able to confirm its existence. The heliopause marks the boundary between our solar system and the rest of the galaxy. Beyond this point, Voyager 1 has detected a steady increase in cosmic rays, particles that come from outside our solar system. This tells us that Voyager 1 is now in interstellar space and that our solar system is just a speck in the vast expanse of the Milky Way. Perhaps most intriguingly, Voyager 1 has detected a mysterious hum that permeates the entire universe. This hum is caused by plasma waves, and it's been dubbed the interstellar hum. Scientists are still trying to figure out exactly what causes this hum, but its existence suggests that there's far more to the universe than we currently understand. Despite being launched over 40 years ago, Voyager 1 is still communicating with Earth, thanks to its radioisotope thermoelectric generators, which provide it with power. And as it continues its journey through space, it's likely that it will continue to make discoveries that challenge our understanding of the cosmos. But the discovery of the heliopause is just the tip of the iceberg when it comes to Voyager 1's contributions to our understanding of the universe. As Voyager 1 ventured further and further into the outer reaches of our solar system, it captured another mysterious and intriguing phenomena that left scientists scratching their heads. Voyager 1 discovered the existence of a magnetic highway at the edge of our solar system. This highway is created by the interaction between the solar wind, a stream of charged particles emanating from the sun, and the interstellar medium, the material between stars. The magnetic highway is a barrier that slows the solar wind and allows cosmic rays outside our solar system to enter. Another mysterious phenomenon that Voyager 1 captured was a series of cosmic tsunamis that swept through the outer reaches of our solar system. These tsunamis are caused by massive shockwaves propagating through interstellar space, compressing and heating the material in their path. The origins of these cosmic tsunamis still need to be fully understood, and their effects on the surrounding area are still being studied. The most chilling discovery made by Voyager 1 was the eerie silence of interstellar space. As the spacecraft left the heliosphere, the region of space dominated by the sun's magnetic field, it entered a much quieter area than expected. The lack of any detectable interstellar hum or buzz left scientists wondering whether the emptiness resulted from an instrumentation error or was a true characteristic of the region. Besides that, the Voyager also captured the ribbon of energetic particles that appeared to be shaped like a giant bow or ribbon stretching across the sky. This ribbon is believed to be the result of the interaction between the magnetic fields of our galaxy and the interstellar medium, but its exact origin and properties are still the subjects of intense study. Now it is time to address why NASA will be shutting down such a historic mission. NASA had to make some tough decisions about allocating resources as Voyager 1 continues on its journey. It is important to know that NASA is not shutting down the Voyager mission entirely, but they will be shutting down some of its instruments. The decision to prioritize power allocation on the probe's instruments is meant to extend their lifespan a few more years and to make sure they hang in space till 2030. These probes are losing their power at a rate of 4 watts per annum, so it automatically becomes one of the most critical factors behind NASA's decision-making process is the limited power supply of the spacecraft. Voyager 1 is powered by a radioisotope thermoelectric generator, or RTG, which converts the heat from the natural decay of radioactive isotopes into electricity. The power output of the RTG decreases over time, meaning that the spacecraft's instruments must be turned off one by one as the power supply dwindles. In 2020, NASA announced that it had turned off the Voyager 1's cosmic ray subsystem, or CRS heating system, which measures the intensity and distribution of cosmic rays in space. This decision was made to conserve power as the spacecraft continued to travel further away from the Sun. The CRS had already exceeded its expected lifespan by several years, and NASA determined that its collected data was sufficient for scientific research. NASA must also consider the limited bandwidth for transmitting data from Voyager 1 back to Earth. The spacecraft uses a 23-watt transmitter to send its data, which is then received by NASA's deep space network of antennas and radio dishes. Besides that, the signal weakens as it travels through the vast expanse of space, meaning that only a limited amount of data can be transmitted at any given time. NASA has implemented a priority list of Voyager 1's instruments to optimize data transmission, determining which data should be transmitted back to Earth first. This list is based on the scientific value of the data and the urgency of the research. Data from Voyager 1's magnetometer instrument, which measures magnetic fields in space, is a high priority because it can help scientists better understand the interactions between the solar wind and interstellar medium. So, while NASA has kept Voyager 1 open, the agency has had to make difficult decisions about managing the spacecraft as it continues to explore the outer reaches of our solar system. What medium does Voyager 1 use to convey the message? Listen to this. The Deep Space Network, a network of antennas in California, Spain, and Australia, is used by Voyager 1 to communicate with Earth. The antennas are made to pick up the flimsy signals Voyager 1 and other deep space missions transmit. A transmitter, a high-gain antenna, and a low-gain antenna are all part of Voyager 1's communication system. A low-gain antenna is utilized for close-range communication, and a high-gain antenna is used for long-range communication. The data must be returned to Earth by the transmitter. Voyager 1 must contact the DSN antennas to send data back to Earth. The antennas must be positioned correctly and capable of picking up the weak signals Voyager 1 transmits. Once the connection is established, Voyager 1 sends its data to Earth using a radio frequency signal. The signal is transmitted at a frequency of 8.4 gigahertz, which is in the X-band of the radio spectrum. The data sent by Voyager 1 is encoded in a digital format using a technique called pulse code modulation. PCM is a method of digitally representing analog signals, such as images and sound, by sampling the passwords at regular intervals and converting them into binary numbers. The data is then transmitted to Earth in packets containing a small portion. The packages are sent using the Consultative Committee for Space Data Systems Protocol, a standardized protocol used for deep space communication. The packets are sent at a rate of 160 bits per second, which is incredibly slow compared to modern communication systems. This is because the signal sent by Voyager 1 is feeble by the time it reaches Earth, and the DSN antennas must be able to receive even the weakest alerts. Once the DSN antennas receive the data, scientists begin the process of analyzing the sea of information, vast and complex. The data is received in a digital format and must be carefully pre-processed to ensure that it is free from any noise or interference that may have been picked up during the transmission. This is a critical step, as any errors or inconsistencies in the data could lead to inaccurate conclusions. After the data is cleaned and organized, it is visualized using specialized software tools. This is where the raw numbers start to take on a life of their own, as the scientists are able to see patterns and trends that might not be immediately apparent from the data itself. They can zoom in and out, change the scale, and explore the data in ways that were previously impossible. As they dive deeper into the data, the scientists begin to notice subtle variations and anomalies that hint at the hidden workings of the universe. One thing is sure, despite these and other puzzling findings revealed by Voyager 1, our solar system and beyond are full of surprises and exciting phenomena that continue to confound our knowledge of the cosmos. Remember to subscribe to our channel to get the latest insights from outer space. Click on the video links on your screens to view our other videos to see more space missions like this one. We'll catch you up in the next one. Until then, take care.